Welcome all of you to yet another session of Swadhyaya. Today we'll learn about the basics of fluid mechanics and what is required to learn this interesting course. Now, as we all know that everything we see in this world or which we cannot see in this world is fluidic in nature. Whether you talk about the flowing water, whether you talk about the air that you breathe in, or whether you talk about a simple race car, or whether you talk about a simple car. Whatever it is, fluid mechanics has its hand in everything that we see right now. Not only what we see, what we cannot see, and what we can see, such as space exploration. Now we all know that there is no matter in deep space. But yes, there are planets which have a different atmosphere, different set of gases, different set of, we can say, the properties of survival required. The air, the water, everything can change. But the concept of fluid mechanics remains the same, because whether it's air, liquid, gas, any other thing, it comes under the term of fluid. And this fluid we can see anywhere out there in the entire galaxy. So this is a very common term, what we call as fluid, and this is very important for us to learn and to understand them, so as to live with it, because we have to live in this world which is built up of these concepts. Now this was a short, this will be, I'll make it short for the fluid mechanics part, but what is the main thing is, whatever the reason which you are going to learn this course, it's very important that you apply this course, right? So whether you are dealing in becoming an engineer, for which this course is made up of, obviously, or whether you are dealing with let us say research aspect, right? Because there is a lot of emphasis on research, because we can't continue to read the same matter again and again, because we have to find, we humans are explorers, we can't sit like that. We have to explore new areas of knowledge, new domains to expertise. So that is what the whole thing is going to be about. So whether you are talking in engineering aspect, research aspect, or just to increase your knowledge base, this is a very advantage, this will give you a very advantage and in a very good vantage position from whatever reason you are going to learn it. So this is what is a basic introduction here, and without further ado, we'll just begin our learning experience here. So fluid mechanics, as you all can see here, so we'll have the basics and introduction part. Now this is a specialized course which is being given by the Swadhyaya channel, so I request all of you to please like it, subscribe it, and even share it. So this is very important aspect, whether you are revising for exams, whether it's an engineering course, or whether you are refreshing your concepts regarding fluid mechanics. As I told you before, many masters or the PhDs, they try to refresh the subjects, because the masters and PhDs go narrower down as we move ahead the career. So in that case, what happens is, this is human tendency, we forget the past topics. So these fluid mechanics is a very basic concept, and we have to keep revising it in order to make it for our freshly brewed content. So whether you are revising, whether you are learning it for the first time, or whether you are just browsing it through for your knowledge base, this will be very advantageous to you. Okay, so let us start. So this is the introduction. What we are going to do, of course, obviously, what is fluid mechanics? The first timers will always be are always welcome to ask this question: what is fluid mechanics? Now fluid mechanics, as we can all see from the term, it is made up of two words, one fluid and the second is mechanics. So we'll deal with it one by one. Let us deal with it one by one, because it makes things easy. Why to complicate things? And the whole universe is made up of simple things, and we shall try to keep it simple. So the first word which is there is fluid, and the second one is mechanics. So let us start with the mechanics part before going to fluid, which requires the mechanics. Both are interrelated, so let us start with mechanics. So what is mechanics for you? Now mechanics is a whole lot of branched out chain. So we have mechanics, and we have two, let us say, the parts of mechanics. One is the solid mechanics, one is the fluid mechanics. Now I'll be telling you what is a fluid, but first we'll see the hierarchy of mechanics. Now solid mechanics, obviously it means the mechanics involving solid bodies or rigid bodies, right? It may be rigid bodies, it may be deformable bodies, just like as you can see here. So solid mechanics again branches out into two, that is the mechanics of rigid bodies and mechanics of deformable bodies. Now this is a whole different course or subject which needs special emphasis on it. Now those who are in the engineering course, before going to fluid mechanics, they have to come across or first have to learn about solid mechanics, because we are going to take very important aspects from the solid mechanics and then we'll be just modifying it to our fluid mechanics. Now this doesn't involve the whole concepts, but we'll be taking some important terms like stress, right? So in solid mechanics you come across the word, you will or you have to come across the term stress. So by the time you come to fluid mechanics, you'll be well you'll be well aware of the term stress, right? So mechanics branches out into two, that is solid mechanics and fluid mechanics. Solid mechanics is again, as you can see, mechanics of rigid bodies, mechanics of deformable bodies. Then we have mechanics of materials and theory of elasticity. These are the two main components or the concepts which are related to mechanics of deformable bodies. Mechanics of rigid bodies is again, we have statics, we have dynamics, and then kinetics and kinematics as a part of dynamics. So we'll come across these terms also, what is statics, what is dynamics. And fluid mechanics on the other hand branches out into two. Well, there are more than two, we'll be coming right in the next slide. So it is hydrostatic or hydrodynamics. As you can see, hydro means the water or the fluid or liquid. So we'll not just be confined to hydro only. We'll see in the next slide what is it. So in the next slide, as we can see, the fluid mechanics, which is made up of three main important aspects. The hydrodynamics. Now what is this hydrodynamics? Hydrodynamics is nothing but it is a study of incompressible fluids. Okay, it is a study of incompressible fluids, the practically which cannot change its density. Incompressibility means which cannot change its density. Now they are practically liquids. Yes, liquids you cannot change the density. Gases, yes, they can change, but gases at low speeds, gas which is flowing at low speeds, also come under the category of incompressible fluids. So what we have here is, we have hydrodynamics, which is the study of incompressible fluids. Practically these are liquids or gases at low speeds. Next we come across gas dynamics. Now gas dynamics, as you all know, obviously the name is sufficient, it refers to gas. So gases which are flowing, okay, the gases which are flowing, whether they may be at high speed, whether they may be at low speed, but these gas dynamics, under the concept of gas dynamics, the density of the gas will change. That is the main aspect to be kept in mind. If the density changes, that is the fluid now becomes compressible. Now you can compress the fluid. That is what happens in compressed air. When you go to a service center, whether to service your bike or car, you may have noticed the bike or car being lifted. So that bike or car may be lifted due to your pneumatic action, that is using air, or it can be lifted due to your hydraulic action. So we'll come back to that also, very important applications which we have. So in that case, what we are doing is, we are making sure, if we are using pneumatics, that is we are using air, we are compressing it and then using it depending on the usage. So that is what is pneumatics. And gas dynamics, so the main, it is not restricted only to the compressed air. Now gas dynamics is a very important concept which has to be learned when the fluid or when the gas flows through a nozzle. Now we know a nozzle, what it is. You can see, if you want to see a nozzle, just remember the back side of the, or the rear side of a jet plane. So again, or the rocket launchers. Okay, so these are all nozzles from where gas flows, the hot gases flow. So two important things to be kept in mind: one, the density changes in gas dynamics, and next we'll have fluid flow. That is mainly fluid flow happens at very high speeds. So that is gas dynamics. Now we come to the very important aspect, that is aerodynamics. Now aerodynamics is again what we call as the flow of gases again here, but here we are making sure the gas here used is air, right? Aerodynamics, air, makes sense. So flow of gases over the bodies. The body may be an aircraft, it may be a missile, it may be a rocket, it may be a car, it may be a bike, it may be a cycle, anything. So whenever we are talking about flow over bodies of gases, especially air, then we talk about aerodynamics. This is very common aspect to you. Based on this aerodynamics only, designs are made so as to save fuel if you are riding a bike or riding a car, and to make sure they move or they go faster, right? So we'll come back to this, what is this all, and then we'll see. Now the next important thing in our aspect is mechanics. What actually mechanics means? So actually mechanics is nothing but a study of motion and the forces which cause or may prevent the motion. And we have, first is the statics. Statics means the study of forces acting on the bodies or particles at rest. So if the body or particle is at rest and there are the net forces which are acting on these bodies at rest, so that is known as static, or the branch of mechanics dealing statics. Next we have dynamics, also known as kinetics, where the particles or the bodies are in movement or in motion, and then the forces are acting on it. So what is causing that force, how is it acting on that body or particle of our concern, is the main agenda for dynamics. Now again, we have this dynamics where it is a study of forces on the particles, but if you are interested only on the movement, that is how the particles are moving, so there is also a specialized branch for that. It is known as kinematics. So it describes the motion of the particles or bodies, such as displacement, velocity and acceleration. So here we have tried to take mechanics down to its bone structure or a cellular structure. So these three are very important for the study of mechanics. So these are very elementary, and the prerequisite, one of the prerequisite to study fluid mechanics is mechanics itself, the engineering mechanics. So the viewer or the listener who wants to learn has to have these three in command for them to be able to move forward in fluid mechanics, right? Now we'll come back to what is a fluid, right? A fluid is nothing but is a substance in liquid or gas phase that is referred to as fluid, right? Now fluid, if you really what you mean is something which has the ability to flow, right? It can be liquid, it can be gases. So something which has the ability to flow is known as fluid. That is a layman language. So if you are moving for more technical language, it is nothing but which can deform itself, without need of a stress, right? So there is a distinction between a solid and a fluid on the basis of the substance ability to resist an applied shear stress or tangential stress. Now that is why the one of the prerequisite I said earlier was solid mechanics, because in solid mechanics you will learn about stress, you will learn about the types of stress. So one of the types of stress is tangential stress or shear stress. So it can be a normal stress that is perpendicular to the surface or perpendicular to the area of consideration, or it can be on tangential, that is shear stress. So that is the main distinction. We'll come back to the main distinctions here also. So fluid is nothing but which can deform itself under the action of a very small infinitesimal shear stress. That is the technical definition, and we all know the layman definition, that is a substance which has ability to flow.